Good evening. The next new chapter of your class 11 syllabus, and that is vectors. And we are going to divide it into small lectures because we have to go in detail for your mains and advanced preparation. In today's class, we are going to see what are vectors, what are the different types of vectors, how do you show and represent a vector, the unit vector notation, how to calculate that unit vector along any direction, and how to find the magnitude of a vector if it is given in IJK form. So all of this in today's lecture, and then we'll move on to addition and subtraction in the next class, and then the multiplication, dot and cross product in the class after that, right? So going steadily, going consistently, every day 6 o'clock, 11 syllabus for 2027 and 2026, and at 8 o'clock for the class 12 syllabus, that's for 2026 students. So quickly join in, let me know whether you're a class 11th student or a dropper student or a class 12 student clearing up your backlogs. This is me, your Captain Shreyas. That is my quick introduction. I did my BTech from NIT Nagpur and research from IIT Bombay. And I am here training kids, nurturing them, guiding them for the past 13 plus years. So this year, it's your turn to make your seat, pre-book your seat in IIT, in your favorite college for 2027 or 2026, right? So let's begin the class and let me say hello to everyone. Abhijit completed the vectors, very good. So maybe it will be a quick revision. Hi Tharuna, 11th standard. Madhukar, 12th. Wow, hi. Very nice. Hi Raudhi. Oh my God, what a name. Hi Surya, good evening. Hi Akhil, a dropper. Hi Anurula. Hi Amina. Yes, there will be PYQ solving as well. And last lecture we just did. Where did it go? See, where did it go? Where did it go? Where did it go? Vernier caliper and micrometer screw gauge. It was an amazing class, and many of you solved the homework and smash the like button, not just of this video, but also of the current video. Many people forget. Do that right now. I'm giving you some time, and subscribe to the channel. The PDFs will be available in the description box as well as in the comment section after a day. Okay, very good, Vesak. Anantiraj, Shipali, Slochna, Yogita, Kuluma, crazy. Yes, I am from Salem, Tamil Nadu. Okay, yes. And many people have understood the concepts right now. I'm so glad that you are enjoying the teachings on the Vedantu JEE English channel, which is also your #1 channel in the country in English medium. It's a blessing for so many students out there. Hi, good evening, SR. Hi, Sunflower, new subscriber, welcome. All right. So let's begin with the lecture. And here is all about first scalars and vectors. First, let me talk about vectors and then we'll go to scalars. So vectors are basically those quantities like, for example, force, displacement, acceleration, field, momentum, all these things are vector quantities. Velocity, position, so many others, etc. These are all vector quantities, and one thing common in all these quantities is that you need the value, which is basically the magnitude. That means how much is the force, 10 Newton, how much is the momentum, 500, how much is this velocity, 79, whatever magnitude, that is basically the value, and it is an and the direction. Both are compulsory. You cannot just give one. Both are needed. I cannot say the force is acting in north direction. I can't say the displacement is upwards. No, I need to tell, oh, it's 10 meters displacement in the upward direction. Both magnitude and direction are important. And one last thing about vectors is that they follow the rules of the vector addition and subtraction. They follow the rules of vector addition, subtraction, whatever it is. So that is compulsory. Just because it has some magnitude and direction does not make it qualify for a vector. For it to qualify as a vector, this also is essential. It should have some direction, it should have some value, and it should follow those rules. Only then it qualifies as a vector. Whereas on the other hand, if you talk about scalar quantities, many examples are there. Like for example, distance. I have traveled 10 kilometers. You need not tell me which direction. Or speed. What is the top speed of the vehicle? It is 200 kilometers per hour. You need not tell me the direction. Or time, or basically mass, or let's say for example, maybe current. Yes, current. Or let's say some quantity like energy, or let's say work. All these things, power, all these things. Okay. Or let's say even you will see quantities like, okay, we have done so many things like even density, right? All these things are scalar quantities. They just need their magnitude. Magnitude is enough. Magnitude is enough to describe them. You don't need direction even if it has any. Like for example, current has direction. Current flows in a wire in one direction, but nobody gives the direction of the current. It is understood it goes from high potential to low potential, or from positive to negative in a wire. So that is one thing, and it doesn't even follow the rules of vector addition. So even though current might look like it has direction, or sometimes even people believe time has dimensions, but in the 4-dimension space. So normally the world we see is in 3D, but the 4-dimension, imagine some superpower was able to see some 4-dimensional figures, then time has a direction from past to present to the future. But then it does not follow the rules of vector addition, so it is not a vector quantity. So doesn't it doesn't follow vector rules. It doesn't follow the vector rules of addition, subtraction, whatever it is. You can't add them like vectors. You can just use their values enough to add them. So like 2 kg and 3 kg becomes 5 kg. But it is not compulsory that 2 Newton force and 3 Newton force makes 5 Newton. Because if the forces are in the opposite directions, they might partially cancel, and 2 Newton from here and 3 Newton from here might balance out and give you only a 1 Newton force. So that is the reason why I'm saying vector rules are different, scalar rules are different. For scalars, direction not important. For vectors, both magnitude and the directions are important, and they must follow the rules. Only then they qualify for vectors. Is that right? Okay. It will take 3 lectures, Kulumala. Yeah. Right. Hi, Abhijit. Welcome. Yes. Yes, Raj. Perfect. Yes, Taruna. Electric current is a very special example. But then, how do I show a vector? Like, for example, force or momentum or velocity or position. So, because they have direction and some magnitude, we need to somehow show them graphically. So, to specify the length, or sorry, the magnitude, we use the length and the direction with an arrow mark. So, usually vectors are shown like this. The length corresponds to how big is this, corresponds to how big or small the value is, and the arrow mark always points and gives me the direction in which it is pointing towards. So for example, okay, say I tell 10 Newton force in the east direction versus 20 Newton force in the east direction versus 30 Newton force in the north direction. So how will they look like in each situation? For example, in the first scenario, 10 Newton force in the east direction might be this much. 20 Newton will be double of this, so it might be twice as lengthier as this. 30 will be thrice as lengthier as 10, 10, 10, 10, 3 times, but it is in the north direction, so maybe it is over here. So these are how you represent the vector quantities in the graphical or in the diagrammatical form. So the arrow mark is called as the head of the vector. The other end is called as the tail, just like an arrow, right? It has a tail, it has a head. The head will give me the direction of it. Is that right, everyone? Yep, perfecto. Awesome. But sir, is there a way to also write it in the mathematical form or in the symbolic form? Is there a symbol for vector? Yes, of course, there is a symbol of vector. And say for example, I want to talk about the force or velocity or any vector. So the vector can be represented like this, v with a bar on it, or or you can also use v with an arrow mark on it. Books sometimes use a bold symbol, but we cannot put bold because it's difficult to draw. So either this or this is a way to represent a vector quantity. But in this particular method of representing, understand, it's not that the arrow mark is actually pointing in the direction. Many people I have seen, they think, sir, if the vector is in north, I will do like this. If vector is in the south, I will do like this. Vector is left side, it is like this. Vector is right side, it is like this. No guys, that is not how it works. This is just a symbol that, listen, there is direction and magnitude in it. Listen, it's a vector. Listen, you need to give me two things. You need to tell me the value and where is it pointed. So that is how you represent a vector. So maybe it's a vector like this over here, v bar. But sometimes the tail might be given a letter, let's say O or A or B or C or something. Let's say, for example, A. The head might be given some symbol P, Q, R, A, B, C, O, whatever you want, any alphabet. Let's say it is the symbol B. It's going from point A to point B. So then I can also represent this as, O, A bar or OA with a arrow. One and the same thing, guys. All these are just symbols of vectors. When you use two alphabets, please keep in mind that the first alphabet is always the tail and the second alphabet is always the head. So please keep in mind that OA vector or AO vector is not the same. It is definitely not going to be the same. In this case, I think the tail that I have taken is A and the head was B. So I should use the same symbols over here. So tail is A, head is B. Tail is A, head is basically B. So I can use like this. AB bar, AB arrow mark, whichever way you prefer. When you use a single alphabet, then there is no way to understand which is the head, which is the tail. So, you can use it for shorthand, or when it is like not needed, which is the head or tail, then you can use a simple single alphabet. Is that right? Everybody with me? Clear till this point? Yeah. November is the target Zoro before November. Yeah. Magnitudes are always positive. Yes, we are coming to that now. So, say for example, if I take, if I take a square, or let's say some kind of polygon or some kind of a geometrical figure, I can mark points A, B, C, D, all right, and like this. So I can make so many vectors out of them. For example, vector AD bar. Can you see vector AD bar? Vector AD bar, it's from A to D. So that is basically this vector. Then I can also make vector BC bar, B to C. Can you see both these vectors like this, B to C? Oh, their magnitudes and directions are same. So can you say that they are equal, guys? Can you say that they are actually equal vectors? Everybody with me? They are equal vectors. Yeah. Similarly, imagine this particular vector. Vector A B bar. A B bar means from A to B over here. A to B over here. What about vector CD bar? C to D means it is over here like this. It is over here like this. Oh, wait a minute. They are same in magnitude but opposite in direction. So can I put a minus sign over here? Can I put a minus sign over here saying that it's negative of the other vector? So AB vector is negative of CD, or CD is negative of AB. Negative means same value but opposite in direction. Same value but opposite in direction, isn't it? Thank you so much. Thank you so much. Loving my teaching. So glad. Another example, assuming this is a square. If I draw this particular vector, what will that be? It will be basically DB vector. It will be DB vector. If I show from A to C like this. This will be AC vector. A to C will be like this. They will be perpendicular to each other. So I can just put a perpendicular symbol because I know diagonals of a square are always at right angles. So that is how you can use two alphabets to represent a vector. Maybe you know some points and you want to use those points as tails and heads over here. So this is how you can use it. This was just an example. Okay, so coming back, so there are different kinds of vectors. Let's talk about them. Like and unlike vectors, which I just told you. So like vectors means, like vectors means, like vectors means same magnitude, same magnitude, and same direction, same direction, same magnitude and same direction. So then I will say A vector is equal to B vector. Unlike vectors means same magnitude, same magnitude, same magnitude, but opposite direction, opposite direction, opposite direction. So A vector is, let's say, negative of B vector. So then I will say they are unlike, or sometimes I can call it as negative vectors also. Negative vectors. Okay, so better word for this instead of using unlike will be, let's use negative vectors. That is better. Okay, negative vectors. Negative vectors. Okay, very important. So B vector is negative of A or A vector is negative of B. That means opposite in direction, but you can see their magnitudes, their lengths are going to be the same. All right. So moving on now to the next concept. Moving on now to the next concept. What about the magnitude? How do I show the magnitude of a vector? The magnitude of any of these vectors can be represented like this. So the magnitude of a vector, for that use the symbol of modulus. Use the modulus symbol. Use the modulus symbol. Modulus symbol. Modulus symbol. Meaning something like this. V vector mod, or V vector like this with an arrow mark mod, or you can also use AB vector mod, or you can also use AB arrow mark and then modulus, which can be also then written down as just AB, or which can also be just written down as just plain and simple V without the modulus. But usually use the mod symbol, that's okay. But if the mod is not there, then don't write the bar. So all of them are exactly the same thing. Whether it is this, whether it is this, whether it is this, or whether it is this or this. So when I don't put the bar, I'm basically measuring the length of AB or the length of the vector V. Okay. So when you put mod, it means magnitude. And magnitude of a vector will always be positive. Yes, it will be always positive. It will always be positive in number. Makes sense. Maximum, it can be 0, but definitely not negative. So always positive or 0, but it can never ever be negative. 0 is also possible. All right. So we'll come to what is velocity in that chapter of kinematics, but velocity, vaguely speaking, is nothing but a vector which tells you what the speed is and with the direction. So it's kind of the vector version of speed, but with the directional aspect. That's a overall or a summary kind of a definition, but the exact definition I'll give you with terms of displacement and time. All right. Okay. Yes, there is no mod, but there is mod. So what do you call that vector which has no magnitude at all? It is called zero vector, and sometimes also called null vector. So null vector or null vector, null, null or zero vector, null or zero vector basically has zero magnitude. Zero magnitude. Very important. Zero magnitude. So if I take a vector V, whose magnitude is 0. Therefore, I can conclude V vector is a null vector or a 0 vector. So vector with 0 magnitude is called as a null vector. Okay. So if you have to represent it, I'll just put it as a point because it has no length. So just put it as a point. That's it. It becomes a null vector. Okay. Let me ask you this very famous question, very important question. Let's see how many of you can give this. What is the direction of a 0 vector? Quickly answer in the chat box right away, right now. What? Yes. What is the direction of the 0 vector? The warriors, I am teaching in the Sigma batch. As you can see, the link is there in the description box of this particular video itself as you are watching. Yeah. But in the pro batches, you have other teachers. And in fact, some of the pro teachers are also teaching in the Sigma batch. All right. So you have the JEE Pro batches right over here. And if you want the Sigma batch, that link for 2026 is here. So Sigma batch is for 2026, droppers or 12th standard students, but for freshers, 2-year people, then go for the pro batches. Yeah. But the teachers are like me only. I mean, better than me, or you can say like me only, because in Vedantu, all the teachers go through some 6-7 rounds of interviews. There are tests which are conducted, then there is demo which is conducted, video lecture which is conducted. So all of them are NITians, IITians only. So you won't find much of a difference, right? Very good. Not determined or no direction, or rather, basically, direction is not defined. Directionless. Directionless. Very important. So a 0 vector is always directionless. It has no direction which is defined. There is no sense of direction. I mean, what is the point of telling my speed is 0 kilometers per hour in north direction? Okay, be happy when you say north. What's the point? My speed is 0 kilometers per hour in the east direction. How does it matter? We don't argue with such fools. We just say, hey man, you are lost it. When your speed is 0, why are you telling me the direction? Just keep quiet. Don't tell me the direction because you're not even moving. So directionless, or basically no need of specifying it. There is no meaning of it. All right. Now, since we have understood how do we show a vector, how do we symbolically write it, how do we write the magnitude of it, and we have seen a couple of type of vectors. So there are many type of vectors like 0 vector, unit vector, position vector, co-initial, like and unlike, parallel, anti-parallel, coplanar, collinear, displacement. So many different types of vectors. Let's go one by one. So first we just spoke about the 0 vector concept, which has no magnitude at all. Then the next one, unit vector. Okay, but before going to unit vector, let me just remind you of this. Yeah, the like vectors and the negative vectors, same direction or opposite direction. Okay, this also we did. Now we'll talk about unit vector. This is also very important. Unit means what? Unity means number 1. It's a very special number like 0, 1 and infinity. One of the most famous numbers in mathematics, right? 0, 1 and infinity, right? So unit vector means it has a magnitude of 1, has a magnitude of 1. Direction can be anything. This is very important. Can have any direction. It can have any direction, doesn't really matter as long as the magnitude is 1. Now see guys, if I tell you vector v bar modulus is 1, then I can easily conclude v vector is an unit vector, But sometimes I don't like to, always say these many words or these many symbols I don't want to use. I can just use a simple way of representing a unit vector, and that is nothing but just say, for example, v hat. V hat means it's a vector whose magnitude is 1. So when you put that symbol, that small hat like symbol or cap like symbol, it means it is a unit vector. So v hat or a hat or b hat or c hat, anything, any alphabet you can use, I hat or z hat or y hat, all these are basically unit vectors. All these are basically unit vectors. So v hat is always an unit vector. Always an unit vector. So whenever you see this hat, let's say a hat, and there is a mod 100% it will be 1. So just for clarity's sake, let me use a different symbol, A hat or B hat, anything guys. So if I use over here B hat, modulus, it will 100% be 1. Is this absolutely clear, my dear students? Yeah, what is the meaning of an unit vector? Oh, no problem, Vasuki. Attendance marked. Join in. Yes, Gautam. Vectors of magnitude 1. Yes, Taruna. Correct. First PU portion, Girish, by first PU portion will be done by November max. Yeah. All right. Null vector is 0. Direction will be anything or not defined. Yes. Cap or hat. Okay. So what is this symbol called? This particular symbol is called as a cap or a hat, whichever you want, cap or a hat. But there are 3 special unit vectors which we have in physics. 3 special unit vectors. Can you see over here? This is basically, for example, the x-axis. Let's say this is the y-axis. And let's say this is the z-axis. A unit vector in the direction of the x-axis is called I cap. A unit vector in the y-axis direction is basically called j cap, and a unit vector in the z direction is basically called k cap. So I cap, j cap and k cap are the special symbols which we use for only those unity vectors in the x direction, y direction and the z direction. So I cap, j cap and k cap, they are basically are special unit vectors in x, y, z respectively, directions respectively. Okay, we'll be using this in the later part of the chapter. Okay, in today's session only, we'll be using it very soon, I, j, k. But if I use a hat or z or something else, some other symbol, it can be any direction. But when I use I, j, k, it means something. It is in the perfect direction of x. Okay, I, j, k. Perfect. Moving on to parallel, anti-parallel. Okay, look at this, guys. These are parallel lines. These are anti-parallel lines. These are not parallel. Very simple. So when they have same direction, when they have same direction, when they have the same direction, they are said to be parallel. They are said to be parallel. Okay, parallel. But when they are opposite in direction, opposite, they are exactly opposite in direction, two vectors. Magnitude can be different, guys, or same, doesn't matter. Then they are said to be anti-parallel. Anti-parallel. They are said to be anti-parallel. Okay, I don't have so much space. Let me use it over here. They are then said to be anti-parallel. Anti-parallel. Now, this is completely different from being not parallel. Here, they are not parallel. They are not parallel. They are not parallel when they basically intersect. Intersecting vectors, whenever they intersect, basically when they are not parallel or anti-parallel, then they are said to be just not parallel. So not parallel is not the same as being anti-parallel. Anti-parallel means specifically opposite in direction. Okay. Now quickly think and tell me, are equal vectors parallel or parallel vectors equal? Always. Quickly answer in the chat box. Are equal vectors parallel or parallel vectors equal? Answer it in the chat box. No, vector cannot be curved. So we do not have curved vectors, guys, in physics. It cannot. Simply cannot. Okay. Rather, if I have many vectors which are lined up like this, then I can have something called as the resultant of these vectors like this. It will be the net vector, but we do not have curved vectors in physics like this. Okay. Yeah. Yes. Equal vectors are parallel. Parallel vectors may or may not be equal. Like for example, these two vectors over here, they are parallel, but they are not equal. So it is not compulsory. But if two vectors are equal, compulsorily they must be parallel. How about anti-parallel? Are negative vectors anti-parallel or anti-parallel vectors negative? Try to recollect negative vectors. Negative vectors. Are anti-parallel vectors negative or negative vectors always anti-parallel? Come on, answer it in the chat box. Very good, Sunflower, Taruna, Gautami. Come on, Aninta, Rama, Abhijit, Raj, Nilima. Very good, guys. Come on, Vasuki, Gautams. Yes, think about it. Think about it carefully. If you have opposite lines, they might be equal in magnitude, may not be, but if they are if they are negative, 100% they must be anti-parallel. So negative vectors are always anti-parallel, but just because it is anti-parallel, it may not be negative. Yeah, is that clear, everyone? With me on this? Yeah. So like over here, all right, just take this particular example. This vector and this vector, they are 100% anti-parallel, but not negative of each other, as you can see, right? Because they are not of the necessarily same magnitude. Yep. Yes. Perfect, Sunflower. Yeah. Girish, I meant ki which condition implies which. So if it is negative vector, can I conclude that it is anti-parallel? Yes, 100%. But if it is anti-parallel, then can I be sure it is negative? No, maybe, may not be. So just because it is anti-parallel does not mean it is negative of each other. Same thing, if it is in the same direction, their lengths may be equal, may not be equal. So it may be equal, it may not be equal. But if it is equal, 100% their directions will be the same. Is that okay? Girish, got it? Perfecto. Yeah. Moving on to the next one. Coplanar vectors, meaning they are in the same plane. So maybe the floor, maybe the side walls or the roof. If the vectors are in the same plane, they are coplanar. If they are not, then they are non-coplanar vectors. As simple as that, right? Everyone, just this is a three-dimensional concept. If vectors are in the same plane, then they are coplanar. If one vector is here, one vector is somewhere else, then they are going to be non-coplanar vectors. Very good. Next one, collinear vectors, meaning they are along the same line. Like another example of collinear vectors can be this one, this vector and then maybe this vector. They are all collinear vectors. So definitely they are collinear vectors along the same line. But say for example, this vector along with maybe this vector and maybe along with this vector, they are 100% non-collinear. Non-collinear. They are 100% non-collinear vectors. Is that understood? So if they are along the same line, maybe same direction or non-same direction, collinear. If they are not in the same direction, they are 100% non-collinear vectors. These are simple mathematical terms as well. Okay, sir. Now I had to put one more thing. Yeah. Okay, this one, position vector. This is also very important. Position vector. So what is the meaning of position vector? Position means it points towards the current location. So position vector will be a vector pointing to the final or the current location of the particle. So that is the meaning of position vector. What is your position? So from the origin, you will draw a arrow mark towards your current location. That is the position vector. Usually the symbol of a position vector is R bar. So usually you will use R vector as or R as the symbol of position. All right. So usually the symbol of position vector is a small alphabet R with a bar on it. All right. Now comes the last thing over here. How do I measure angle between the vectors? Not many people teach this. Angle between the vectors. Angle between the vectors. This is very, very important, guys. Observe it carefully. Imagine I have been given two vectors like this randomly placed anywhere. Okay, it could be anywhere, just really doesn't matter. Okay, some two vectors are there. And I want to measure what is the angle between the two vectors. What do you need to do? Always join their tails or their heads coincide with each other. So let's move them. And one way is, okay, this vector is as it is over here, and the other vector is over here, or this vector is here, or this vector is here, and this vector is here, like this. Either their tails should coincide with each other or their heads should coincide with each other. Once they do, then measure the angle between them. That is the correct angle between two vectors. That is the correct way of measuring the angles. But let's say some of you might draw some vector over here like this and might show another vector like this. And then you will be like, sir, I thought I can measure this angle. This is not the right way of measuring the angle. This is not correct. This is incorrect angle. This is incorrect angle. See, if you slide this vector over here, if you slide this particular vector over here and bring it over here, then this vector and this vector's tails will join, and then this particular angle is the correct angle. So this is the correct way of measuring it. So if this is theta, technically this will be nothing but 180 minus theta. So this will give you the supplementary angle, not the actual angle. Supplementary is the other angle which will add up to give you 180 degrees, right? Like complementary adds up to give 90, supplementary gives up to give you 180 degrees. So always make sure that the vectors are, in the tail or head form. Just to give you a simple example on this, let's see whether you are able to get it. All right. Imagine I show a vector construction something like this, and I say that, listen, this is vector A, this is vector B, and this is vector C. What is the angle between A bar and B bar? What is the angle between B bar and C bar? What is the angle between C bar and A bar? So what is the angle between, all these three things? This one, and this one. Come on, think about it and give me the answer. This, and this. All right. Quickly think in the chat box and answer it. What is the angle between A and B, B and C, and A and C? Yeah. Yeah, you can use pi minus theta if it is in radians. 180 minus theta will be in degrees. It's obvious that if it is in radians, it will be pi minus theta only. Yeah, Rama? Correct. Sir, but how will you find the angle between velocity and displacement? Well, there are multiple ways. We'll use dot product. Yeah, there is dot product to find the angle between any two vectors. But if you don't want to use dot product, you should know how they look, where are they pointing towards, then you can find it out. Okay, it's not a big deal. You just need to know which direction they are pointing. You can easily find it. Else you need to know the values of those vectors by which you can find it using dot product. We'll come to dot product in the third class. Yeah. All right. So in this particular scenario, as one can see over here carefully, that if I take vector A and B, this is the head, this is the tail, so not the right way. So I should slide the vector A more up and keep the vector B over here. Then that would be the right way. So this is A vector, this is B vector. I have taken this particular vector A and slided it up. So think about it. Usually this angle was 60 degrees. This was 60 degrees. So this will be 120 degrees. This is the right way because now both their tails are together. So the correct answer between A and B is 120 degrees, or you can use 2 pi by 3 radians. One and the same thing. 2 pi by 3 radians. How about B and C? Well, for B and C, you don't have to do much because their heads are already coinciding at the same place. Can you see vector B and vector C, their tails are already coinciding, and the internal angle of an equilateral triangle will be 60 degrees. Oh, sorry, I'm so sorry. I forgot to mention it's an equilateral triangle. So I'm mentioning it over here. This is an equilateral triangle. Equilateral triangle. All right. So coming back, so the answer for this will be 100% 60 degrees, or I can also say this is pi by 3 radians. How about A and C? For A and C also I don't have to do much because already their tails are coinciding with each other. So as one can see, A vector is over here, C vector is here, this is that angle. So that is basically 60 degrees. So this is also again 60 degrees, or basically pi by 3 radians. Is this understood, my dear warriors? 120, 60 and 60. That is the right answer. If you wrote 120, 120, 60, that is incorrect. Many of you got it incorrect. Yeah. Yes, Gautam, actually C is the resultant, but we have not yet talked about what is the resultant. We'll come to it in the next class. But for now, yeah, this is how you can solve the questions on angles. Okay. Be very careful now, because throughout physics, this will not come again. Nobody will teach you. It will be assumed that you already know this. And then during derivations or during problem solving, we'll be like, angle between this is 70 degrees. We'll be like, what? How come it is 70? I thought it will be, something else, 110. Oh, now I understood. I should realign those vectors, tail, tail, or head, head. Only then I can measure the angle. Great. Now, let us come to the main thing, which is the resolution of a vector, which is the main concept of today's class. Now that we have understood it. So, yes, Abhijit, I of course remember you from the previous class, man. Of course. Yeah. Our junior most, or one of the junior most students out here. Okay. Resolution of a vector. Resolve something, meaning you have to split it and figure out what is it made of. Like, say, for example, I give you a car and I'm like, come on, resolve the car. Meaning, this is what Chinese people do. They import BMW and they will break it down. Door separate, window separate, engine separate. In engine also piston, cylinder, everything, ring separate, shaft separate, crankshaft separate, differential separate. They will open it up completely. And then they will see, how was this manufactured? Okay. Full exact copy, cheap. Zoop. BMW will cost you 1 crore. I will give you in 20 lakhs. So that is what Chinese people do. They resolve. But the big, costly components, costly, products. Great. So, oh my God, you are in 8th standard. My God, kids, really, I'm really super duper proud of you. Yeah. So resolution means you are going to split a vector. So resolution is basically splitting a vector. And when I split a vector, I break it down into parts, which are basically called the components. The components, or basically the parts of a vector. Components or parts of a vector. But how exactly do I know what a vector is made of? Like, for example, I give you a vector like this, or I give you a vector like this, or I give you a vector, I give you a vector like this, and I ask you, can you figure out what is it made of? Or I give you a vector like this, what is this vector made of? Then you start wondering, oh my God, what is it made of, sir? Sir, I think I know the answer, sir. Sir, the vector is made of this part, this part, this part, this part, and this part. Sir, if I take all these vectors together, I will get this vector. Very good, correct you are. Nothing wrong in it. Oh yes, sir. Sir, is this the only way I can make it? Not necessarily. There are so many other ways. As long as, see this, you start from the tail and slowly move across, maybe like this, but do not break contact. Do not break contact like this, and then come over here. As long as you start without breaking contact, tail, head, tail, head, tail, head, tail, head, tail, head, and you start from the original tail to the final head. That's it. These are the components of the vectors. What, sir? These are the components. Sir, then I can also make the components for this also then. Sir, this and sir, this. or 100% these are the two components of the vectors. So for this also I can make it this vector, sir, then this vector, then this vector, then this vector, sir, and sir, then this vector, sir, and then this vector, sir. Are these the components? 100% they are the components of the vectors. Sir, if that is the scenario, then I can make as many permutation combinations, so many possibilities are there. Yes, absolutely correct. There are infinite possibilities, infinite possibilities of the components of a vector, of the components of any kind of vector, right? So all these things which I have shown over here, right, these are basically the components. These are the components, and this green part was the actual original vector itself. And there are infinite ways of making the components. Is that right? Yeah. Should the head join or the head tail join? So the original vector's tail should join with the tail of the first component, and then after that, between the components, the head tail combination should work. Like for example, this was the original tail. The first component's tail will start from that, and then the head will join with the tail of the next component. The head will join with the tail of the next component, head with the tail, head with the tail, head with the tail, till you reach the actual head of the final vector. Is that right? I hope I have answered the doubt. Okay. Okay. Sir, but you just now told the tail, sir, head, sir. What is this? I'm not understanding head and tail of what you are teaching. Hold on. Guys, what I just told you was for finding the angles. If you want to find the angle, then keep the tails together or heads together. But do I want to measure the angle here? Do I want to measure the angle here? No. So why will I keep the head and the tail together? So see what is asked or see what needs to be done. Accordingly, you will see in vectors, sometimes the heads are together, sometimes the head is with the tail. Okay. So it depends from situation or the question or the application part. Is this clear, my dear? Very good question, Girish. I hope this is understood. Yeah, there is no need for us to join the tails. Lot of people get confused. Sir, there you told head. Now you are saying head tail. Depends. When you want to go with the flow, just think about it. It kind of makes sense. You don't have to remember this. Don't sit and by heart now. Oh, for splitting a vector, I need to join head with the tail with the head, tail with the tail, head with the tail. No. Don't do that. Think logically. A Pandu walks from here to here. I can say the Pandu, instead of walking like this, the Pandu could go like this, and come like this. So it's like in a flow, a natural flow, tail, head, tail, head, tail, head. So it kind of makes sense. Also think, why would we measure the angle between two vectors with their tails or their heads joined? Because then there will be a confusion. Some kids will say, sir, the angle is 60 degree. Some students will say, no, sir, the angle is 120. Now, who is correct? So we need to make a convention or a rule. Okay, listen, every time you want to measure an angle, always keep their tails together. Okay, sir, fine. It's very simple and easy then. Okay. Is that clear, everyone? Fair enough. Sir, but this, what you are telling, infinite possibilities, how is it going to help me? There are so many ways. So which way do I, and why do I even need to do it? Okay, why do I need to do it? You will understand it probably in the next lecture, maybe to the end of the today's lecture. But the only way which I find it useful to resolve the vectors is when if I have a vector, and I take the components in such a way that both of them are perpendicular to each other. Yes, both of them should be perpendicular to each other. Only then, when both the components are perpendicular to each other, so I'll just put it over here. perpendicular components. This is the vector itself. Then these components are called rectangular components. Rectangular components. And they have a very, very important role in physics when I split it perpendicular. And the reason is very simple. Just think about it. If I have a vector which is like this and I split it into two components like that, let's say one is along the x-axis and the other one is, let's say, along the y-axis. Okay, say for example, this is the x component. Let's say this is the y-axis. This is x-axis, this is y-axis. This component being along the x-axis, this being the original vector itself, this component which is along the x-axis, why not call it Vx, which is now the x component of the vector, which is the x component of the vector because it is along x. This component is along the y-axis, so why not call it the y component of that vector v. So now I can say that our vector v bar has been resolved into two rectangular components, Vx bar and Vy bar along the x and the y axis, So I found the x component and the y component which are separately along the individual axis. What is the advantage of this? I can use Pythagoras and trigonometric ratios. So the best use of this is I can use the Pythagoras theorem. I can also use trigonometric ratios. I can also use all the properties, if needed, properties of right angled triangles, if at all needed. So it becomes very useful then. If I split it like that, yes, I can make up some of my own properties of polygons, but it is very scary and lengthy and not so easy and convenient. But the moment everything is perpendicular, I can use sine theta, cos theta, tan theta, cot theta, trigonometric identities, perpendicular properties, all right. I can use Pythagoras theorem. All these things suddenly make sense to me that, oh, now I can, find out these components. I can use some properties to find out other component or the vector itself. So much of benefit for me. Got it? So that is why we are going to use always perpendicular or rectangular components in our physics. Yeah. Yes, I use this in electrostatics ring derivation, correct. Yes. So rectangular components, meaning the components are perpendicular to each other. So whenever the components are perpendicular to each other, like for example over here, none of them are perpendicular. This is also not perpendicular, but maybe here this is perpendicular, then these are perpendicular components. But let's say somebody else makes the components like this and then like this angle is not 90 degree. Or somebody makes the like this and like this is not 90. But in a very special case, when it is perpendicular, then only it is called orthogonal or rectangular components. Is that clear now? Perfect. Karuna? Absolutely. Yes. Okay. DDLC, maybe you can put up a comment after the video and I can answer it to you. Okay, sir. Sir, what if it is in 3 dimension? Oh, don't worry, man. If it is in 3 dimension, you will maximum get 3 components. How, sir? Observe this. Imagine a cuboid. Everybody knows a cuboid, length, breadth, height, everything could be different. Imagine this is our vector, okay? This is our original vector over here. This is our vector v over here. Okay, this is our vector V. I can bring it down to three components. How, sir? Observe. One is along the x-axis. So let's say over here. So this is basically your x component. Let's say Vx bar. Then let's go to y component. Where is y? Y is over here. Y is over here along that side. So this is your, let's say, y component. And sir, finally z. So along the z axis. So let's say over like this. So this is basically your Vz component. This is your Vz component. So our original vector, you start with the tail, start going like this, then like this, continue the same flow. Don't break the flow. Don't change the arrow mark or else you will get messed up. Okay. X, then Y, and then Z, and you are finally reaching the end goal. So just imagine a pandu crawling like this from here to here. You can make the pandu go like this, then like this, then like this. So X, Y, and Z, three components. What is the maximum three-dimensional components which are perpendicular possible? Answer that in the chat box. So what's the maximum rectangular components that a vector can have? Come on, answer this in the chat box. Yeah. Right. Abhijit, I don't think so. There was a student of ours, all India rank 2. That was back when I was in Pune and in offline centers. And in Pune, offline, all India rank 2. Many of my kids got all India rank 14, 15, 9, 32, staying in, a normal city, guys. There is no need of quota. Quota, there was a time which it had its charm, but now it doesn't, right? Maximum possible components. Hi, Preeti. Welcome aboard. Yeah, three components only. Maximum three. You can't have more than three, which are perpendicular. Yeah, correct. So if you want to visualize three-dimension figures, always visualize a cuboid. Now, the room that you're sitting in, just pay attention to the room. Don't even look at the screen. Just listen to what I'm saying. Just go to the center of the room. If you're wearing headphones, just go or just make the volume up. And imagine the height, length, and the breadth of the room. Look at one of the corner, that is your origin, and the diagonally opposite corner on the top. So if there is one corner below, go to the diagonally opposite corner on the top as the vector itself. Just visualize that body diagonal like this one, from one corner to other corner. Now, on your floor, make one edge of your room as Vx component, the other edge as the Vy, and the height as your Vz. So one breadth might be Vx, the length might be Vy, and the height might be Vz. So automatically you will get a three-dimensional figure. You should visualize it on your floor and your walls. One component going like this, like this, like this, and multiple ways of visualizing. Some student might start, sir, can I start with Vy first, sir, or Vz first? Why not? First go Vz, then go Vy, and then go Vx. This is also possible. This, and this. Why not? Sir, I visualized it somewhat different, sir. What is it that you visualize? Sir, I visualized Vy first, and then I went Vz, and then I came to Vx. Yes, that is also possible. So many possibilities are there, but all of them are rectangular components in 3 dimension. All of them are rectangular components in 3 dimension. Yeah? Yes. I hope this is absolutely clear. Absolutely clear. Here the x, y, and z are marked differently. That's why I have taken x here, y here, and z here. But usually we take, I know, x like this, y like this, and z like this. But in this diagram, x was here, y was there, and z was here. So that's why I have chosen accordingly. Okay? Not got confused. Don't worry. Clear now? Yes. Awesome. Pandu is back. Yes. Vx and Vz. Vx is fine, and Vz is also fine. Okay, it's fine for this particular diagram, but usually we will be using something else. All right. So sir, tell me now. So sir, tell me now, if I have a vector like this, and let's say these are the axes possible. These are the axes. Okay, let me just show some axes over here. And let me show the vector itself like this, be like this, maybe like this, maybe like this. These are our vectors and we want to split it into components. Vector V, vector V, vector V, vector V. I want to split it into multiple components. So how do I do that? Starting from the first problem, I want to split it into two components which are perpendicular to each other. As one can see, I can write one component like this and the other component will go directly over here. So obviously then this is my x component of the vector, this is my y component of the vector, along the x, along the y. Everybody is able to see it? Everybody is able to see it? Sir, can I also do one more thing? Can I do this vector and then I do this vector? This is also correct. Yes, why not? This is Vy vector and this is this is Vx vector. This is also fine. In fact, let me tell you one thing, guys. Forget all this for a moment. If I had this particular vector, let's just get rid of this. If I had this particular vector, I can split it either like this and like this, or like this and like this. Both are fine, guys. Both possibilities, both resolutions are okay. Both the resolutions are completely okay. There is nothing wrong in it. Okay, this is Vx, this is also Vx, this is Vy, this is Vy. Both are fine. You go like this and like this, or you go like this and like this, you will reach there. So usually you will see sometimes people taking a vector and either they will use this or the other way, or you can just say this is Vx and this is Vy. This is also the same thing, Vx and this is Vy. Nothing wrong in this. These are the two components. I have taken this vector, I split it up. Just open up that vector. Goes like this, zoop, you open it up. Something in x, something in y. Is that absolutely clear? Yeah? Everybody with me understood? So say for example, if I had this vector over here, I have so many possibilities of opening this vector up. Like one of the possibility is going like this and then going like this. Other possibility is going like this and then going like this. Both are fine. Or somebody might choose just like this and like this. This is also fine. This or this, it is the same thing. Both are fine. Okay, I can go like this, I can go like this, or you take this part and this part, it's the same thing. So this is 100%, this is Vx, this is Vy. This over here, this is Vx, this is Vy. This over here, this is Vy, this is Vx. Nothing wrong in any of these splitting methods. Done? Raj, first throw your phone away, throw your negative friends away and negative relatives away, and make a study room or a study place. If you don't have a room, a study place, and worship it like a temple. Start doing it and follow this consistently for the next couple of days, and then let's see what kind of other distractions you get. Maybe it could be TV or gaming. So start throwing one things away. Simple, nothing else. And if you can't throw it away, buy a new dumb phone. Nowadays people are started buying dumb phones, not smartphones. So dumb phones are where you don't have WhatsApp or anything else, or basic YouTube is there or something. That's it. Only educational apps you can download, and you can lock out all the apps. So that is the best way. No TV. Ask your parents also not to watch TV. No other music systems, anything. No going to movies. No hanging out with random friends. Hang out, enjoy, play games, play sports, play music, but it should not become interfere. There is a difference when things start to interfere. You should do all the extracurriculars, but just let it not interfere. Okay, starting off with the next question, guys, over here. I can split it up like this. So, sorry. I can split it up like this, and the other component, I can show it here also, or I can show it here also. There is no harm in showing it like this. Here, I can split it up here, and the next component, if you want, I can go down like this also. Yeah, if you don't like that, no issues. We can throw it over here also. It's one and the same thing. These are the two components. How about this scenario? I feel there is only one component. Yes, only x component. And what about the y component? The y component is not there. Rather, the y component is 0 because there is nothing in the y direction. Yeah, there is nothing in the y direction. Everything is in the x direction only. Is that right? Yep. Okay. Raj, unless you have some girl issue, then it is a different story. Okay. Now, what about this? You can go like this and you can come down here, or you can go like this and you can come down here, or you can just make it go like this and somewhat like this. This is also perfectly fine. Nothing wrong in this. Is that right, everyone? So these are the different ways in which you can resolve a vector and find the components. Okay, sir, I understood now. Sir, but what is the value of these components? Sir, you took all these components, no? Sir, what is the value of these components? It's very simple. I'll tell you what. You take any vector, doesn't matter. You take any vector, and let's say one of the component is like this. One of the component is like this, and the other component is like this. Chumma, I've taken it like this, guys. Okay, just imagine this is the x-axis, this is the y-axis. Your axis can be tilted also, no? Who says that x has to be always towards the right side or y has to be always upside? No, it could be anything. So these are your x-axis and y-axis. Chumma randomly I have taken. Okay, this is your vector v, and obviously this is your x component and this is your y component. Okay, this is your x component and y component. If some person uses Pythagoras theorem, by Pythagoras theorem, one can easily say hypotenuse square, which is v square. So from that we can get v. So v square will be nothing but vx square plus vy square. So whatever is this length squares it and add it, you will get the hypotenuse square. So v will be nothing but the root of vx square plus vy square. So v will be nothing but root of vx square plus vy square using Pythagoras theorem. Now similarly, using trigonometric identities, say for example somebody says, hey listen, this is theta. Okay, let's say this is theta. So one can easily say cos theta is adjacent, which is nothing but vx, divided by hypotenuse, which is v. Similarly, one can say sine theta is opposite, which is vy, by hypotenuse, which is v. So from this, we will get something in cos theta, and here also we'll get something in sine theta. And what are those? So from here we will get vx, and from here we'll get vy is nothing but v cos theta or v times sine theta. So vx is v cos theta, vy is v sine theta. That's what we got. Amazing. Not just that, somebody might argue, no sir, for me this angle is theta. Okay, so then for you cos theta and sine theta will be something slightly different. So we'll have something into cos theta and you'll have something into sine theta over here. So what will be cos theta and what will be sine theta? Just think, for that person cos theta will be nothing but vy by hypotenuse. Sine theta will be opposite side, that means vx by hypotenuse. So for that person here vy and this particular vx would be nothing but v cos theta, and this will be v sine theta. So vx is v sine theta and vy is v cos theta. So things can differ depending on which angle you have chosen. So you can use all these things for solving your questions. Trigonometry or Pythagoras theorem. Sir, but this is very confusing, sir. This trigonometry, give me an easy rule. I mean, why are we wasting so much time? All right, fine, bros and girls. I'll give you an easy way to solve this. You take any vector, man. You take any vector, and let's say these are the two components. One component is over here, and let's say the other component is over here. Doesn't matter how the vector is, which axis you are taking, doesn't matter. Just imagine this is your x-axis, this is your y-axis. Okay, Chumma, I have taken something. Okay, this is x-axis, this is y-axis, this is my vector itself. Let's say you choose this angle. Let's say I call this theta. This component is closer. This component is closer to the angle. Closer, C for close, C for cos. So this component will be nothing but V times of cos theta. C for close, C for close, C for cos. The side which is the component which is closer to theta will be cos theta. If you see this particular component, this is far away, far from theta. This is far from theta. So what I will say, the moment you are going far, that means you have committed a sin. So therefore, it will be V sine theta. So the moment you are far, it is a sin. The moment you are close, it is a cos. Very easy to remember. Got it, everyone? Yes, V over there was the magnitude. Where did it go? Here, this is the magnitude of the vector. This is basically the magnitude, because I did not put any bar or anything, right? So this is magnitude. So this is the magnitude. Yeah. So closer is cos, far away is sine or sin. So let me show you some examples on this. Say for example, we take a vector here, then 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 a vector here, every time, of course. Those are the axes and those are our vectors. Let's say this is vector V. Let's say this is a vector of magnitude 20. Let's say this is a vector A. Let's say this is vector of magnitude, something like 5 root 2. Okay, here also. This is a vector of magnitude C. Let's say this is a vector of magnitude 100. Let me start marking those angles. Let's say this is basically, let's say this is basically theta. Let's say this is basically 30 degrees. Let's say this is nothing but 60 degrees. Let's say this is nothing but 45 degrees. Let's say this is nothing but 30 degrees. Let's say this is nothing but 60 degrees. I want to figure out the components in each scenario. Okay, start by showing those components first, then let's find out the value. Here I can split it like this and like this. Here I can split it like this and then like this. Here I can split it like this and then like this. Here I can split it like this and then like this. Here I can split it like this and then like this. Here I can split it like this and then like this. These are the components of those vectors. These are basically the components of those vectors. Okay, the first stage is done. Next stage, what are those values? What are those values? We can find it out easily. The closer one is cos, so that means this will be V cos theta. This is far away from theta, so V sin theta. The moment you go far, you commit a sin. Lot of people remember X means cos, Y means sin. That is absolutely nonsense. Okay, all right. This is closer to theta, so this will be 20 cos 30. This is far away, so this will be 20 sine of 30. This is closer, so this will be A cos 60. This is far away, so this will be A sine of 60. This is closer, so this will be 5 root 2 cos 45. And this is far away, so this will be 5 root 2 sine 45. This is closer, so this will be C cos 30. And this is far away from 30, so C sine of 30. This is closer, so 100 cos 60, and this is far away from 60, so 100 sine 60. Understood how to get the components? If you want to find the values, it is very easy. For example, cos 45 is 1 by root 2, so 5 root 2 multiplied by 1 by root 2, so that will be 5. This will be also nothing but 5 root 2 into 1 by root 2. So this will be also 5. So these have two components which are 5 units each. Same thing, you can find the value of cos 30, cos 60, whatever, and you can get the answers. Is this clear? Should I go back and watch from the start or continue the leftover part? Teja, if you already have learned till resolution somewhere, then you can continue. But if you have no head on clue what is happening right now, better to watch from the start. Okay, there is no harm. I explain it very beautifully right from the basics, making you understand every single concept. Okay, so better go step by step if you do not know all these things from before. Okay, sir. Understood, sir. Sir, let's take some questions. Resolve a force of 8 Newton which makes an angle of 45 degrees with the horizontal. So let's take a force whose value is 8 Newton. Okay, so this is basically 8 Newton and it is making 45 degrees with the horizontal. It is making basically 45 degrees with the horizontal. Okay, so the vertical is like this. So the next step, what will it be? Resolve the forces, meaning take a component like this and take a component like this. So the one which is closer to angle will be cos. So this will be 8 cos 45. Cos 45 means 1 by root 2. So hence this will be 8 by root 2 newtons. This will be 8 far away means sin 45. Sin 45 means 1 by root 2. So hence it will be 8 by root 2 newtons in the y direction. So the x component is 8 by root 2. Y component is also 8 by root 2 newtons. So that is the answer to this question. Moving on to the next question. All right. Resolve a weight of 10 newtons in the directions which are parallel and perpendicular to a slope inclined at 30 degrees with the horizontal. So let's draw a slope. This is a slope which is making right now an angle of 30 degrees with the horizontal, and weight means it's a force. So that force is like this and it has a value of how many newtons? 10 newtons like this. So this is the diagrammatic representation of the question. Weight will always act towards the direction of the gravity. So gravity always acts down. So that's why I've shown the force of 10 Newton also downwards. Okay, sir. So we have to split it in two directions which are parallel and perpendicular to that slope. So this was our slope. So basically this was our slope. So parallel means like this, perpendicular means like this. Okay. So as you can see, I can take a component like this and obviously the other component will be like this, right? This is basically perpendicular, this is basically parallel. If you still want me to convince you, well, look at it. I can just draw a rectangle over here like this. I can just draw a rectangle over here just so that you are convinced. Yes, sir, this is now a rectangular component. I could have easily drawn this over here. So this vector and this vector gives me 10 Newton, or I could have shifted this vector here. So this vector and this vector again gives me 10 Newton. It doesn't matter as long as I'm splitting it perpendicular to each other. So 100% they are perpendicular to each other. So these are the two components. So this is the perpendicular component. This is the parallel component. But I don't know theta, sir. Don't worry. I will give you a very easy trick to do all these kind of problems. What you do is observe, draw the inclined plane, draw the horizontal. What is this? This is our slope. This is our horizontal. Now also draw a vertical. What is this line? This is a vertical line. And then draw perpendicular to the incline. This is basically perpendicular to the slope. This is perpendicular to the slope. 30 degrees is exactly which angle? It is the angle between horizontal and the slope. Horizontal and the slope. So basically, I know this angle as theta. I know this angle. So what you do now, my trick is draw vertical, horizontal, slope and perpendicular. Show the angle which you know. Then leave one part, leave one segment, go to the next segment. Automatically, that will be theta. Leave the next part, go to the next alternate one, that will be theta. Leave this segment, go to the next one, that will be theta. Leave this, it will be theta. So every alternate part will be theta, and that is the trick. Wow, sir, that is so cool. So how can I use it here? Observe, this is vertical, this is perpendicular. This is vertical, this is perpendicular. So can you quickly guess this particular angle, how much will it be? Between vertical and the perpendicular, same angle theta. That means this should be 30 degrees. Is this absolutely clear how we figured it out? Is this absolutely clear, everyone? Yep. Awesome, awesome. So now the last part will be to mark the values. This is closer, so cos, so this will be 10 cos 30. Cos 30 is nothing but root 3 by 2. So this will be nothing but 5 root 3 newtons. This is far away from angle. So this will be 10 sine of 30. Sine 30 is nothing but half. So this will be just 5 newtons. So parallel component is 5, perpendicular component is 5 root 3 newtons. Yeah. So just to go with the problem again, this problem said there is a weight will always act down, and we had to split it into two parts. I had to split it. There were multiple ways of splitting it into two parts, which are parallel and perpendicular. One way was to go like this and then like this. Another way was to go like this and then like this. And another way, of course, was to split it like this and then like this. All three are the same thing only. Okay, these are all obviously the perpendicular components. Okay, this is also perpendicular. These are basically your parallel components. This, the yellow one here, blue one here, or the pink one here. This yellow, this pink, and this blue all are perpendicular to this vector. But to find the component, I need to know either this angle or this angle. I don't know anything. So I will take the help of this angle. So now, in order to find out which of these angles is 30 or 60 or whatever it is, I gave a trick. And what is the trick? You divide the figure into 8 parts. Horizontal, slope, vertical, and perpendicular to the slope. As you can see, this is perpendicular, this is vertical. Yeah, this particular thing, this is basically in the vertical direction. This is in the vertical direction. As you can see, this was horizontal and this was along the slope. That's it. So if you know this angle is 30, every alternate angle will be 30. So if this is 30, 100% this angle should be 30 by that logic. Okay, because this will be 30, this will be 30, this will be 30, and this will be 30. Is that now clear? Once I get the angle, I can write down the closer one is cos, the far away one is the sine component. All right. Yes, William. Yes, it's a decent book. Why not? You can definitely use it. Hi, Harnos. Abhijit, now clear? Yeah. Gautam's clear. Yes, Rama. Perfecto. Understood. Yeah, these are some critical questions. Okay. Look at this JEE Mains question. This came in the year of 2023. The vector in the xy plane makes an angle of 30 with the y-axis. The magnitude of the y component of the vector is 2 root 3. The magnitude of the x component of the vector will be how much? Think of the vector diagram. Makes an angle 30 degrees with the y-axis. Okay. So first let me draw our y-axis, and this is our x-axis. So this is y, and this is x. The vector is making an angle of 30 degrees. The vector is making an angle of 30 degrees with the y-axis. The magnitude of the y component is 2 root 3. The magnitude of the y component, that means this much, is basically 2 root 3. Question is, what is the magnitude of the x component? So x component will be obviously this one. This is your x component. So they have asked how much is basically the x component. So first draw the diagram, then things will become easier. I have an idea. Why show the x component here? I think of using some trigonometric ratio. Shift this x component here, doesn't matter. So this is also our x component, and this is 90 degree. So look at this right angle triangle. This is opposite side, this is adjacent side. It is obvious that I can use the trigonometric ratio of tan, which is opposite by adjacent. Opposite, I don't know. Adjacent is 2 root 3. Tan 30 is 1 by root 3. Root 3 cancel. So 1 by 1 is Vx by 2. So therefore, Vx will be 2 units. So 2 units means option B is the right answer. So this question came in J. Clear? Yes, the answer is 2. Yes, Haron, welcome. Yes, Trupti, very good. B option 2. Perfect. Clear. Abhijit, Gautam, Teja. Is it easy to extend the weight direction and then it forms a right angle triangle, then we get 60 degree? Yes, that is also easy way. Where did it go? Yes, this one. Yes, you can do that also. So you can then do this, you can extend it, then do this. This is 90 degree, this is 30, then this is 60. If this is 60, then this is 30. That also is perfectly fine. Nothing wrong with that. Okay. This method, I'm giving it to you because you will see in the future, this method, you will love it. Anytime any inclined plane comes, you don't have to extend anything. Just horizontal, vertical. Okay. This angle is 30. Every alternate angle will be theta. Immediately you can get the answer. But yeah, there are obviously multiple geometrical approaches, like, you can say that these two are parallel lines. This angle is 30, so this is an alternate angle, so this will be 30. Okay, if this is 30, then this is 60, and then this is 30. So many ways you can get the answer. So it's about the matter of convenience then. All right. Moving ahead now to the final unit vector representation, and this is the best part of it. See, look at this. If there was a vector, if there was a vector like this, and I told you, hey, listen, this is the x component, and let's say this is the y component, this is x component, this is y component, and this was the vector itself. What if I tell you, listen, the x component value is chumma something like 6 units, and let's say the y component is nothing but 8 units. They are both perpendicular to each other. If you ask me what is the total vector's magnitude, immediately I will use Pythagoras theorem and I will say it is 6 square plus how much? 8 square, which is 36 plus 64, which is root 100. Therefore, the magnitude of that vector is 10 units. Root of 100 is 10 units. Isn't it? Yes, sir. Correct. Another thing. Remember, I had defined some special unit vectors along x direction, y direction, and all of that. This was the x direction. This is the y direction, right? This is the x direction. This is the y direction. A unit vector along the x direction, what is it called? I cap. And unit vector along the x direction, what was it called? Basically, I cap. A unit vector along the y direction, it was called j cap. So let me write this I cap over here and let me write this j cap over here. Imagine I take I cap and put it 6 times. I cap, I cap, I cap, I cap. I will get the total vector Vx bar. Won't I get? Vx bar will be 6 times of nothing but I cap. Same thing, j cap, j cap, j cap, I put 8 times. So if I take j cap, how many times? 8 number of times. Won't I get the vector Vy itself? Oh yes, sir. Why not? Also, I have taken the vector V and I have split it up into 2 parts. One part is Vx bar, other part is Vy bar. Combining both of them, if you combine the parts or the components, then you will get, if you combine both these parts, then you get our original vector V, our original vector V. But wait a minute, what is a Vx bar? Vx bar is nothing but 6 times of I cap. And what is Vy bar? Vy bar is 8 times of our j cap. 8 times of our j cap. Combining both of them, I get my vector V. Oh, this is such a beautiful way of writing a vector. 6 I cap, 8 J cap. If anybody tells me, immediately I will think I cap I have to take 6 times, tuck, 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 6 times. J cap I have to take 8 times. So this is X, this is Y. So this is my vector. Done, dusted, sorted. Isn't this an easier way to represent the vector? Yeah. If you take a unit vector multiplied with a vector, does it change or remain the same? It will change, obviously, edit gamings. But when I'm multiplying here, it is a scalar. So 6 times of I cap will make it a new vector who is lengthier and by 6 times. Okay, it is 6 times the original vector. All right, perfect. Okay, sir, I understood now. So tell me one thing. If I give you a vector like this, minus 3 I cap plus 5 J cap, or if I give a vector like this, I cap plus 3 J cap, or if I give you a vector like this, minus 2I minus 3J, or a vector like this, 3I cap minus 2J cap. How will these vectors basically look like in our XY diagram? So X, Y, X, Y. Okay, how will they basically look like? Think about it. Starting off with this one, the first one, minus 3I means opposite to I, go 3 times, and 5J means go 5 units upwards, like this. So my resultant vector will be basically like this. Is that right, everyone? Minus 3I plus 5J. This one, minus 2I minus 3J. So minus 2I means go negatively in the direction of X. 3 times J means go down, not up. And the resultant will be basically this one. Resultant will be this one. This 3I minus 2J, go in the direction of I cap, that means X direction 3 times. And 2J cap negative means downwards like this. So the resultant is going to be this way. Again, for this particular question, I cap plus 3J cap. So I cap means only once, 3J cap means 3 times like this. So the resultant will be like this. This is how the resultant will be. Is this absolutely clear? How do we show vectors? Now, very easy to draw, visualize it in the IJK notation. If somebody asks you, what is the magnitude of this vector? What is the magnitude of 3I cap minus 2J cap? When they are putting this mod symbol, they mean find the magnitude. Find the magnitude. What will you do? Immediately, you will take the X component, you will take the Y component, square it, add it. So this will be 9 plus 4, which is basically root 13. So quickly, you can find the magnitude of it. Any vector that is needed. Is this absolutely clear? Yep. If somebody asks you what is the angle made by, let's say, for example, this vector with the negative x direction. So quickly, I want to find this angle, no issues. I know the height of this. I know the height of this. Height is basically 5 units. I know the base of this. This is 3 units in length. So quickly, I can use the ratio of tan theta. So tan theta will be opposite by adjacent. So theta will be tan inverse of 5 by 3. That's it. So tan inverse of 5 by 3 is the angle made by the vector with the negative x-axis. Easily doable. So you can find angles, you can find magnitudes, you can get a feel, look of where the vector is, and a very easy way to write it down. Yeah. Yes. You can definitely change the number, Suresh. Just write a mail to VCare and it should be done. Yeah. But sir, what if the vector is in 3 dimension? Don't worry, guys. I mean, here it's not that diagram which I want, but still, I'll just rewrite it. This is our so let's say this was our vector. This was our vector, V vector, and we have our I cap, and then J cap, and then K cap over here. This is I cap, this is J cap, and this is k cap, and then you show the components. So this whole thing, then this whole thing, and then this whole thing. These are your components of the vector. So this is your x component, this is your y component, this is your z component, right? Assuming this is x-axis, this is y-axis, and this is z-axis. This is how traditionally we show. So we can say that our entire vector v bar is the sum of three components. Our entire vector v bar is the sum of three components. Which are those components? Vx bar, Vy bar, and Vz bar. And each component will have some magnitude, which is Vx, Vy, and Vz, along with their unit vectors, I cap, j cap, and k cap. The magnitude of the vector, the magnitude of the vector v bar will be simply you take the root of the squares of those components being added. Vx square plus Vy square plus Vz square. That's it. So this is how you represent the vector in unit vector notation, and this is the magnitude of the vector. Instead of just x square and y square, which we did over here, there will be three squares which will come. That's all. That's the only difference. So this is something which obviously everybody should remember. Is this absolutely clear, my dear students? Done, dusted. Shall we look at some questions? Yeah. Hi Durga, shall we look at some questions? Ready for it? Put some fire emoji. And if you've forgotten to smash the like button right now, do it. Many people forget to mark their attendance. Smash the like button, answer in the comments. Just like last session, I will show your names in the next session. Those of you solve the homework. Today's homework I'm going to give you. Don't worry. Okay, sir. Let us see. Let us see the first question on your screen. The x and y components of a force are 2 Newton and minus 3 Newton. What is the force going to be? Well. My force is this vector F, and it will be the sum of two forces. So the magnitudes of the components, x component, how much it is? 2 Newton. Y component is minus 3 Newton. And this will be obviously x component means I cap, y component means j cap. So 2 I cap minus 3 j cap. Where is it? Option A. Yes, perfecto. That is option A. Is this clear, everyone? Yes, Virupaksha. Yep. Tell me whatever your doubt is. Okay. What is the numerical value of the vector 3i, 4j, 5k? What is the numerical value of the vector 3i, 4j, 5k? What do you do with this? Numerical value means nothing but the magnitude of the vector. So essentially what they are asking is, what is the magnitude of 3i cap plus 4j cap plus 5k cap? Well, the answer will be, take the components 3 square, 4 square, and 5 square. So what is this going to be? 3 square is 9, 4 square is 16, and this is basically 25, isn't it? Perfect. So what is 9 plus 16? That is 25. So this will be nothing but root of 50, which is the same as saying 2 into 25. So 25's root is 5. So it will be 5 root 2. So 5 root 2 is B option. That is the correct answer. Very good. Yes, Durga. Yes, Girish, Durgesh, Abhijit, Gautam. Awesome, Teja. Awesome, Rama. Very good. Yep. All right. Will tough questions be asked in JEE? 100%. Why not? Now, I mean, you should be prepared for a tough question only. And remember, vectors is like the base of everything. Very rarely they will ask a direct question on vectors, because vectors is like you use addition, subtraction everywhere. So they won't ask question on basic things. So they will always use vectors in problems. It's like a part of basic maths. Usually this is taught as basic maths only. The vector joining A and B is how much? Okay. Now these kind of questions, be careful. Observe what it means. Imagine there is a point A over here. Imagine there is a point A over here. This is a point B over here. And a vector joining them means this vector. this is that vector that I want to find. So if you know the points, then this vector v will be nothing but, you take the difference of the coordinates, maybe x2 minus x1, that will be basically I cap, similarly j cap and k cap. So that vector will be basically nothing but x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Just the difference of the coordinates, that's it. So over here, the vector AB will be b minus a, always b minus a, x2 minus x1. x2 is this, x1 is this, coordinates. So 2 minus 1 I cap plus y2 minus y1 minus 3 minus 1 j cap plus z2 minus z1 4 minus minus 1 k cap. So this will just become I cap, this will become minus 4 j cap, and this will become plus 5 k cap. So I minus 4j plus 5k, which is C option. Absolutely clear, everyone? This is how you find a vector pointing from a point to another point. Just take the difference of the coordinates, final vector minus our initial vector. Very good, excellent. Right. Now, the last part of this session, which is finding a unit vector. Very, very essential. What is the meaning of finding a unit vector? Imagine a question like this comes. Find the unit vector. Find the unit vector v hat in the direction of some another vector, let's say v bar. This type of questions usually come or might be used in some part of a bigger problem. What does this even mean? Let's understand. I have a vector like this, which I call it v bar. It is not a unit vector, it is some length, maybe 5 units, 100 units, 70 units, whatever. A unit vector in the direction of v bar means in the same direction, but the magnitude should be 1. So understand, this length is basically 1 unit. But if you ask me what is this entire length, can you guys quickly think and tell me what is the length of this entire thing? It will be v units. Which is basically, that is the magnitude of the vector v. If the length is 7, the total length will be 7. If the length is 7, the total length is 7, magnitude is 7. Yeah. If the magnitude of this vector is 116, the length of this will be 116. So the magnitude is basically the length. So this gives me a clear-cut picture that, hey, I got to know now, v vector is nothing but, you take the magnitude of it, this and multiply it by that unit vector. So v hat, if you put it, how many times will you have to put it? Yes, you'll have to put it the magnitude number of times. You put it like this, then like this, and then keep on doing it till you reach basically the end. So if you keep doing it, how many times? Like the magnitude number of times. It is 7 magnitude, put it 7 times. It is 8 magnitude, put it 8 times. So 8 times of that unit vector will give me the original vector. So v hat is technically the vector itself divided by its magnitude. So that's how you can find it out. This is also a very important formula. V hat is vector v divided by the magnitude of the vector itself. Let's take up a simple question so that you guys understand the meaning of it. Say, I tell you, Example, find unit vector along 3 I cap plus 4 j cap. This is the question. Okay. So if the question is this, let's try to solve it. The unit vector along any vector is the vector itself divided by the magnitude. So the vector itself is 3 I cap plus 4 j cap. The magnitude of this vector is 3 square plus 4 square. So which will make it 3 I cap plus 4 j cap. 3 square is 9, 4 square is 16, 16 plus 9 is 25. So root of 25. So which is nothing but the number 5, which can be further written down as 3 by 5 I cap plus 4 by 5 j cap. So that is the unit vector along this vector. Meaning, if I draw a vector like this, whose length is like this, 3 I cap plus 4 j cap. If you take the mod of it, we can see the mod of it was 5 units. It was 5 units. So the unit vector is only this much. It's 1/5. If you take 5 such things, then you will get the total vector. So this is our unit vector. And when I say it is 3 by 5 and 4 by 5 means like this. This much is 3 by 5 I cap and this much is 4 by 5 j cap. These are the components together that make it this unit vector. Is this now clear? This is our unit vector whose magnitude is 1 unit. Clear what it means finding a unit vector in somebody's direction? Dheeraj, it depends on what your definition of clear is. Hi Priyansh, welcome. How many months required to complete both the series? Like I said, October, November. Yeah, great. Mock tests you should be writing from October onwards, at least the part test. In Sigma Batch 11th portion covered, yes, Suresh, Sigma Batch covers the entire 11th and 12th syllabus. And the batch entry point is 1st or 2nd July. So if you have not yet joined it, please join it. The link is there in the description. Okay. What is the unit vector along I cap plus j cap? Come on, quickly solve this particular question, guys. Unit vector along this vector. Okay. The vector itself is I cap plus j cap and the magnitude will be 1 square plus 1 square. So I cap plus j cap is there. 1 plus 1 is 2. So root 2. So that's it. I cap plus j cap by root 2. That is option C. Is that right? Yes, perfectly correct. Yep, perfectly correct. Amazing, amazing. Next one coming up on your screen. If this is a unit vector, find the value of C. If this is a unit vector, find the value of C. Yeah. If this is a unit vector, find the value of C. Okay. If this is a unit vector, meaning 0.5 I cap plus 0.8 j cap plus c k caps magnitude is 1. And magnitude of anything means you take the components, square it. Take the components, square it. Take the components, square it and put it under the root. So 0.5 square is 0.25. 0.8 square is 0.64. C square is C square. Square both sides, so it will become 1 square. So 0.25 plus 0.64, that will make it 0.89 plus C square is 1. So C square is 1 minus 0.89, which is 0.11, that is C square. So C will be root of 0.11. So root of 0.11, that is option number B. Excellent. Perfecto. Yeah, very good. So that was the last question. I'll just give you the homework now. So this is your homework. What is the homework? Where will you put the answer? Answer should be there in the comments. And I'm going to read out all the names in the next session. Which of the following is a unit vector? Which of the following is an unit vector? Which of the following is an unit vector? A, I cap minus K cap. B, I cap plus J cap minus K cap. C, I cap minus K cap by root 2. Option D, J cap, sorry, I cap minus J cap plus K cap, whole thing by root 3. More than one options can be correct. You need to figure it out which of the following can be a unit vector. Okay. So that was your homework question. This is the final call also for the Sigma batch in case you are not a part of it, for the entire 11th and 12th portion, which will be covered by October, November. And after that revision, plan for your 2026 attempt and then the final JEE Advanced preparation. And in case you don't crack it, don't worry. Again, the revision will start for your April attempt. All right. So complete batch. You are also getting all my recordings of my previous lectures, which I have conducted many years back. Beautiful lectures plus live lectures are there. It's in pure English, PCM, entire 11th and 12th syllabus with test series, with final revision and with assignments and books, everything as a part of this batch. All right, everything is there. All India test series, mock tests, everything. Okay, so if you are a 2026 student, you should definitely join this particular batch and smash the like button of this video. Okay, the link for the Sigma batch is here. But if you are a 2027 aspirant, please book a demo for our pro batches. The pro batch link is there here, free demo for our pro batch, which is a personalized mentorship batch where you get a dedicated academic mentor, a personal teacher. You get doubt solving even after the batch is over, even after class is over, even during the class. And you have a regular series which continuously goes on. You get an offline feel right at the comfort of your home. Book a demo. Don't want to join? Don't join. But just book a demo. The link is there in the description box. Choose your target year, board, everything. We prepare you for boards also within this pro batch. All right. So that's the best part for this 2-year batch, and even 1-year batch for pro is available. You can check it out. If you want a distraction free batch, you want something which is very, focused, and you want a personal mentorship, many students go for pro, and all the results that I have shown, yes, they are all from our online. Most of them are from our online batches only, right? So thank you so much. I hope you guys enjoyed today's class. I'll be waiting to see you in the next lecture where we'll be doing addition and subtraction, right? Do not forget to like this video and subscribe to the Vedantu JEE English channel. This was your Captain Shreyas. Bye bye. Take care.